integration by partial. So here you need to learn some method related to partial fractions. So in case if you don't know how to do partial fractions, we advise you to go back to what did you call it? Elementary maths, the one our main tutorial. Just check all those ones. We talk about a lot of things concerning partial fractions as well. So, but I will just break it down so that you'll be able to even understand it more. Like for example, the said integral of 1 over x of x minus 2 dx. You see this one? I will firstly solve, because the problem is what I have there, I cannot break it down unless I solve it partially. I want to solve using partial fractions. So now let's take the value that we have in that integrations. I have x over x minus 2. So how are we going to do that? This can be a, and we can use b for this one. Meaning, this can be a over x plus b over x minus 2 for the first one and for the second one. So that means here we have 1 over x minus 2 is equal to, now x sum of this one is x of x minus 2. So this for this, this for this. That is how we have a bracket of x minus 2 plus b of x. So now if this cancel this, we have 1 equal to a bracket of x minus 2 plus bs. I'm looking for a, at the same time I'm looking for b. I cannot find the two at the same time. If I want to find my a, I have to make b to be 0. And if I want to find b, I have to make a to be 0. So anyone you find out of the two is still the same thing. That means if I, for example, to obtain a now, meaning I want to find a, I have to find one value for x that can make this b to be 0. Can you guess the value? Yeah, so we're going to let our x to be 0. You know, if x is 0, if I multiply b by 0, I will have 0. So here we have 1 is equal to a bracket of 0 minus 2 plus b over 0. So here we have 1 is equal to 0 minus 2. We are going to have minus 2. A times this, we have minus 2a. Then b times 0, we are going to have 0. I'm looking for a. That's our minus 2 minus 2. So a is equal to minus 1 all over what? Minus 1 all over 2. So it will remain b. I will the same way. I will go back here. What I have is 1 is equal to a x minus 2 plus b. So now I want to obtain the value of my b as well. So that means I have to find one value of x that will make this equation to be 0. Which value? Yeah, these are 2, because if I put 2 here, it's going to be 0. To obtain b, so we let x to be 2. So if I put it there, we have 1 is equal to a bracket of 2 minus 2 plus so let me check something here. So now then b of 2. So here we have 1 is equal to this and this. That's going to be 0. So I have 2b over 2 over 2. So that means my b is equal to 1 all over 2. So let's see. So now we have obtained the value of our, so we can make a simple substitutions to the equation. So that means what I can have now is integral of 1 over, what I have is a over x plus b dx. So I can substitute. My a is this. My a is minus 1 over, this is minus 1 over 2 over x dx plus integral of 1 over 2 over x minus 2 dx, just like a simple substitutions. Then for the first one, I can pull out that minus. That is minus 1 over 2 integral of 1 over x dx plus 1 over 2 integral of 1 over x minus 2 dx, right? So integral of 1 over x, I know that's going to be ln x plus 1 over 2 integral of this one, we have ln x minus 2 then plus what? Plus c. So it depends on how they leave their result. So please, it depends. So if it's for the fact that some can even change it to be maybe, like for example, instead of having this, I can just have this one to be 1 over 2 ln x minus 2 minus 1 over 2 ln x plus c. So now, ln, this can go here. I can have ln x minus 2, 1 over 2 minus ln x half then plus c. You get that one? So now I can write this as ln root of x minus 2 minus ln root of x then plus c. So this is ln. I can take 1. Under the law of logarithm, if I have minus, it can change to division, so that I can have root over x minus 2 over root of x. Then this is nothing but ln over root of x minus 2 over x then plus c. No problem? So now, let's see another examples. Which table one? See which table? By parts? Yeah, we haven't reached that side. It's the last part. This is for Math 102. I don't want to. So now, ask him which time are we starting our this thing?
No, the man is coming and will be here by 7 a.m. The
When?
man is coming on Monday
Okay.
and he's coming early.
All right.
Maybe by 8.
Okay. So this is another problem. So the first thing to do is to firstly solve them using partial fractions, as I mentioned. So this, let's take the value that we have in the bracket. What I have is x minus 2, x minus 5, and x plus 1. So how are we going to do that? So this is nothing but a over x minus 5 plus b over x plus 1 for the first one and for the second one. So this is nothing but x minus 2 over x minus 5, x plus 1. So now, if I take the LCM of this one, this is nothing but x minus 5, x plus 1. So this for this, this for this. That is a bracket of x plus 1, b bracket of x minus 5. So now this can cancel this, right? So what I have left here is x minus 2 is equal to a times x. We are going to, or for example, I can have ax plus 1 plus b bracket of x minus 5. What is going to be the next step? I want to obtain a and b. I told you we cannot obtain the two of them at a time. You see that you firstly find your a, then you let your b to be 0. So for example, if I have to find a now, to obtain a, we have to let my x to be, you see what we have here is minus 5. What is going to be the opposite of minus 5? That is plus 5. So I have to let my x to be 5. So that means if I put it here, so here I can have 5. Let me put it here. I have x minus 2 is equal to a bracket of x plus 1 plus b bracket of x minus 5. So now, if I put the values of that, so here I can have x is 5 now. So that means I can have 5 minus 2 is equal to a bracket of 5 plus 1 plus b bracket of 5 minus 5. Are we following? So 5 minus 2, we have 3. So 5 plus 1, we are going to have 6a. So 5 minus 5, we are going to have 0. So divide through by 6. So that means a here is equal to 1 all over 2. So if a is 1 over 2, I can find my b. I'll just go back here. You can see just as simple. Even the one that have cover-up method, if you check our materials, you are going to learn a lot about that one. So please don't forget to subscribe and like our videos. So here, what I have is x minus 2 is equal to a x plus 1 plus b x minus 5. I have to find my a now. I have to find my b. I have to let x to be minus 1, opposite of what we have here. You can see opposite of what we have here is minus 1. So let x to be minus 1 now, so that I can be able to find the value of b. So here we have minus 1 minus 2 is equal to a minus 1 plus 1 plus b minus 1 minus 5. So minus 1 minus 2, of course, we are going to have minus 3 minus 1 plus 1. That one is going to be 0. So this is 0. And we have minus 6b left. So divided by minus 6 minus 6, of course, my b2 equal to 1 over 2, which is half. So meaning a and b have the same value. So I can just make a simple substitutions to find the value of my what did you call it? The value of the integration itself. What I have there before is integral of a over x minus 5 plus b over x plus 1. So now we have already obtained a and b. If I substitute the values, so here we have integral of a is half x minus 5 dx. So b2 is half x plus 1 dx. You know, half is common. I can factor it out. That means that we have 1 over 2 integral of 1 over x minus 5 plus 1 over x plus 1 dx. This one is just like a simple integrations. Integral of 1 over x minus 5, that's going to be ln x minus 5 then plus ln x plus 1. So here, you know, this is ln. We can take any of the two. That means I can have ln 1 over 2. That's going to be x minus 5. At the same time, we have x plus 1. But you know, this is half. It can come forward since we are dealing with our logarithm functions. That one is a ln x minus 5 x plus 1 all raised to the power of half. Even still, this one can be ln all root of x minus 5 x plus 1. Then since it is indefinite, then we have plus c. So please, if you check our material, you'll be able to see there's another one that can involve a quadratic as the denominators, either 3 that we normally use to cover our method. If you check our materials, you'll be able to see all those examples there. So the last one we are going to talk about is using integration by part.